Hello, everyone. My name is Dina. I'm part of the Immerse team at UCSB. In this video, I will go over an introduction to the R package MplusAutomation. This will go over Mplus on its own, using MplusAutomation in R and looking at some descriptive statistics. To access the materials you'll need, they are available on our GitHub, specifically under the repository Intro to MplusAutomation. So go ahead and save this repository wherever you'd like. I saved it on the desktop under the Immerse project folder. So like I mentioned, we are going to look at Mplus, the software, without R. Then we'll go into MplusAutomation. We'll do an identical analysis that we did in the first part, and then we'll look at some data cleaning and screening. So now I have Mplus open, and I'm ready to open an input file. The input file is what you need to work with the syntax, and then we run it to get an output file. Within the repository, you'll see an input file within the part 1 Mplus folder. So in the Intro to MplusAutomation repository, there's a few folders. In part 1 _Mplus, you'll see an input file called basic example. So if we open that, that opens our input file, which already has some syntax for us. We can go through each part of the syntax right now. This is what the basic skeleton of an Mplus input syntax looks like. The input syntax has a suffix of .inp. You'll first want to have a title, so that's just any character that you wish to describe your analysis with. So we have practice 01, explore, type equals basic. And then right below it, we have data, and we want to specify the file here, and that would be in the same folder that this .imp file is located. So for us, it's under part 1 _Mplus. So we want to make sure this basic _example.dat file is also located in this folder, and it is. It's important that it's a .dat file with no columns, column names. So I think if we open it, you'll see that this is the type of data file that Mplus uses. Under data, we have variable, and we want usually 3, at minimum, these 3 specifications, the names of your variables, and they must be in the same order that you see them in the data set. So we saw here, we have the items here, but there is no column labels or variable names, but we just have to make sure that they're in the correct order. Specify missing. So for us, it would be a just a period. I think you'll be able to see it if we do have any missing right here. And the variables we want to use. So it's not necessarily that all the variables in the data set are the ones you want to use. For us, in this example, it is. To make comments in Mplus syntax, just put an exclamation point right before your text, and it'll turn green. And that just notes that it's a comment. And then right after that, we have analysis. And so here is where you would specify the type of analysis that you're using. This will also change constantly based on your model. For now, we're running a type equals basic analysis, which will provide us descriptive statistics of our variables. So this should run, and now we have output. There's a lot that goes into a type equals basic output. but just very quickly, we could see the number of observations here. Missing data patterns, covariance coverage, sample statistics for each item. There's also a descriptive statistics table. And that's it. So what we can do now is do the same exact analysis, a type equals basic analysis, but using MplusAutomation. So now we're going to open up RStudio. Okay, now that we have our RStudio open, we're going to obtain that same mplus.out file that we produced in part 1 using RStudio with the MplusAutomation package. So what MplusAutomation does is it's an R package that communicates with Mplus to replicate the process we went through using RStudio and the R language. So right now I am in the Intro to MplusAutomation project that was located in the repository of this for this video. What we want to do is create our own project. You can continue to just use this one if you wish, but I can go over how to create a brand new one. So you would go to File, New Project, New Directory, New Project, and then you can enter a directory name. So here we can do Intro to MplusAutomation. Same name, just showing you how to use it. Actually, let's change the name to Test, just to differentiate the two projects. And you can put that under the desktop folder that you have for this video. Hit create project. Okay, so now we have a new project called Intro to MplusAutomation-Test. That created a new folder under the Immerse training folder that's under my desktop. So this is the one that I have from GitHub. This is from a previous video that's also on GitHub. And this is the one that I just created. Again, you don't need to do this step. This is just for if you want to organize this material separate from the repository folder. Okay. Now that we have a folder with just the Mplus, the RStudio project in it, we can create a new R Markdown, and this is the file that's going to contain the script that we use with the MplusAutomation package. And we can call this Introduction to MplusAutomation. And then we have a pre-populated template markdown. So what I like to do is delete everything from 11 down and start fresh. I will save this to this new folder, and then we can call it Intro to MplusAutomation. Okay. So what an R Markdown does, it's a file that provides an authoring framework for data science that allows us to organize our reports using text and code chunks. So we can write headings, normal text, and then we can insert code chunks to run any code. So it's just a way to organize our document with our analysis. So we want to run a type equals basic analysis using the R package MplusAutomation. The first thing we always want to do is load our packages. So that's the packages we're going to use for our analysis. And there's usually a few that we always want to load in. So we'll have a new heading, two number signs, note a level 2 heading, and we'll load packages. And to insert a code chunk, we use Control-Alt-I or Command-Alt-I. You can also click here to insert a new code chunk. And I think you can do code insert code chunk. And then we use the library function to load in the packages. We would like MplusAutomation, tidyverse. The Haven package reads an SPSS dataset. The tidyverse is a collection of R packages designed for data science. It's a type of coding style as well. And we'll leave it at that for now. So we'll have these 3 packages. If you try to run this, you may encounter, so these are just regular warning messages or messages that come with the packages or warning messages. So you don't need to worry about that, but make sure that you don't have one that says could not find, or there is no package called MplusAutomation, for example. If you do get that notification, you would want to make sure you install the package by using in the console install.packages, and in quotes, you would write MplusAutomation and then run that to install the package and then load the package. When you install it, you don't need to install it again, but you do have to load it every R session. Okay, so now that we have our packages loaded, we can go ahead and read in the data set. And this data set is in the repository folder. Let's go ahead and move it to our new project folder. So this is our repository folder. Within part 2 _ RStudio, you'll see a data folder. Just move that into your new folder. Oops. Maybe move that into your new project folder that we created. So we can go copy this. Open the new project, hit paste. So now we have this markdown that we created, and then the data set that's from the repository folder. And you should see it come up here. And then we have a few different files, file types of the same data set. We want to use this .sab, which is the SPSS version. Then we can convert it to these other 2. So to read in data set, insert a code chunk, and we want to give our data set a name, an object name. So we'll just call it data with an arrow. We're assigning this data set to the name data, and we're going to use the read _ SAV function because it's an SAV file. One package that I forgot to put is the here package, and that helps us with organizing the file path. So right now our working directory is wherever our project link is, and so when we use the here package, we can specify where within this working directory we want to look. So ours is under the data folder in our current working directory. So we want to use the here function to say here within this working directory, I want to open the data folder. And within that data folder, I have a data set called exploredata.sav. And then we can hit run. Oh, I have to make sure I load in the here package because it said could not find function here. So that usually means I didn't load this package. And then now I have something to look at here. So this is the data set that we are going to be working with. We saw this in part 1. Okay. One quick way we can look at our data is using the summary function, which is a base R function. And you can just insert that directly in the same code chunk and hit Control Enter or Command Enter to just run that first line, and it gives us some quick descriptive statistics. Now we want to convert this SAV to CSV because that's what MplusAutomation uses. So the next thing we can do is convert from SAV to CSV. You can insert a code chunk and use the write_CSV function to convert the existing format to a CSV. And so we want to call the data object that we created here, and then let the R know where we want to save it. So we'll use the here function, and we'll insert it under part 2 RStudio. Actually, that might not be necessary. We'll write it under data, and then the same name, data, but this time it'll be CSV. So we should see it come up here. Actually, if we delete this, then we can rewrite it, and it should come up again. Okay. We can also create a mplus.dat file using R as well, and this is from the MplusAutomation package. So let's also convert from CSV to .dat. Remember that MplusAutomation uses CSV data file formats. The function is called prepare MplusData. We want to specify which data set we're using. And so let's go ahead and read this in. So right now we just have the SAV. Let's read in the CSV. So we'll call it something different. We'll call it data_CSV, but it's the same format. So instead of read_SAV, we're now going to use read_CSV. And then we want to use the here function to call this new CSV formatted data set. We can hit Control Enter to read it in. This is just some information on our data set. And now we have a second data file object. And so it looks exactly the same, but now it's a CSV. And we can use this one to prepare the Mplus data set. And then we want to save it under data. So let's also delete this just to show you. Explore_data.dat. And then now it's created that .dat file. If you want to work directly in Mplus, you can use this data frame. Okay. Now we want to use the CSV. So when we use MplusAutomation, we want to use the CSV format. If we are working directly in Mplus, then we would use the .dat, but we never have to use .dat if we're working in RStudio with MplusAutomation. So let me just make sure that I mentioned that this is an optional step, but this is the format that we want to use moving forward. Okay. So now we're going to run that basic type equals basic model using MplusAutomation. We're going to use the MplusObject function and the MplusModeler function. So what the MplusObject function does is generate an input file and then a data file specific to each model. So it'll also create another .dat file for your information only. We don't actually need to do anything with it. And then it estimates the model. The MplusModeler also creates, runs, and reads Mplus models using the MplusObject function. And then this is where you specify the .out file saved. So what I'm going to do is I'm going to copy the code that is in the GitHub repository. I can show you what that looks like. So here is the markdown that already has all the information we're working with. You can also look at the knitted HTML file to look at what we'll be doing. And right now we are right here. So here's the code that I'll be copying and then putting in our new markdown. That is right here. And then I can go over each one. Okay. We'll call this titles basic with MplusAutomation. Okay. So like I said, we are going to use the MplusObject function to specify the input syntax. So this should look familiar to the part 1 input syntax that we ran in part 1. And you can see that there are similarities in that specification using MplusAutomation with the MplusObject function. So we have the title. Under use variable, we have under variable, we have use variable, and then the items we want to use. Notice that we do not need the names function in the variable part of the syntax because it already knows what the variable names are under that data CSV object. So that's a nice thing about MplusAutomation is you don't need to specify the names variables in order, you know, in case we mess something up or we have it in the wrong order. MplusAutomation ensures that you are working or specify the data you're working with the item names on it. We also don't need to specify missing because your data set should already have that specified. So part of your data screening and cleaning process should ensure that when you read in your data set, it also has the missing specified as well. Then under analysis, we have type equals basic, which is similar here. And then some extra parts to this code is specifying the data set. So under use variables, we want to use the column names of the data underscore CSV object. And then the data set is also the data underscore CSV. Usually these are exactly the same unless they're for some reason your column names are a different object than your data set, but that never happens. So this is one object, one function that we're going to store in this name called mbasic. So we can just control enter, and this is the syntax is stored in this MplusObject function. Okay, the next thing we want to do is run this mbasic object with the syntax in it using the MplusModeler function. And here it'll create a .dat file identical to the one that we created here, but again, we don't use it and we don't need it, but it's just something to create in case you want to open Mplus and rerun things directly in Mplus. But it's letting me know that I'm going to store it in part 2 underscore RStudio folder. Then it's going to have a model out specification, as in where do we want to save the .out file, and it'll be under part 2 underscore RStudio, and it'll be called basic.out. So it's going to save the basic.input, which is going to look very similar to this, and then it's also going to save the .out. Check equals true checks for missing semicolons. Remember that we still need to ensure, except for the title, that there is a semicolon after each line, except also if we have an exclamation point. So we have a semicolon here and here. We actually don't need this one, and you can keep it, but you don't need it. run equals true runs the model, and then hash file name does not add a hash of the raw data to the data file name. And then we can run this whole thing. Oh, it looks like it says it can't open the connection. So this error message means that it can't find the folder that we're working in. And that's because we don't have a folder called part2_RStudio. So we can just quickly create one. And so now it can find that folder that I specified. Okay. You'll see some warnings usually after you run. So you want to make sure none of them are errors. So this one, you'll almost always see it's just letting you know that when you have hash file name equals false, right data cannot be if missing. So it's just letting you know to set to always. This one's saying you don't have a semicolon at the end of your title. You don't need one. This one's saying that, oh, the lines are longer than 90 characters. So you just want to make sure your file path is under 90 characters. And then, so this last one is an error that we want to fix. So every time you run this, you want to make sure that you open your .out file every time just to see what the issue is. So for me, the issue is that I have a file path that is longer than 90 characters. So I want to change my folder name, possibly the Mplus R project name might be too long, or I can change the name of my part2 RStudio folder. Either way, it's too long for it to read the data frame. So I've actually sent this suggestion to the developers to see if there's a way, because when you run it in Mplus, all it needs is, if you remember, all it needs is the name of your data set that's located in the same folder. You don't have to specify the entire file path. But with MplusAutomation, one thing is that it does specify the entire file path. Okay, so let's go ahead and change and shorten our file path to our data set. Okay, so now that we have changed our project name to make our data file path shorter, I've changed it to intro-2. So what you can do is just click here and click rename. And then I also renamed the folder. You just have to make sure that you close this first. Okay, so this should work now. I think if I rerun this. Make sure you reload the packages. And then make sure you read in this data_CSV. And now this should work. And we have the same .out file as part 1, where we first want to look at the output, make sure that there is no errors. Then we can see the descriptive statistics. Great. So now we can go into part 3 for some data cleaning and screening. Okay, so we're going to use that same data_CSV as we did in part 2 and just look at some data cleaning and screening methods for in RStudio. So I've taken the the code and text directly from the corresponding HTML document for this video, and I'm just going to run through it. So in this first part, we will rename the items to something more descriptive. So what we're going to do is create a new data set called new names, and it's going to come from the pre-existing data_CSV object. We're going to use what's called a pipe operator to create a sequence of functions. You can use the shortcut Control-Shift-M, or I think it's Command-Shift-M on a Mac to type this in instead of typing out the % greater than and %. We'll use the rename function within tidyverse to rename the items. So we use the new name comes first, then equals the old name, and that will rename all of the variables. So we're going to use more descriptive names. So if we run that, you'll see now these are different names. So we can look at the descriptive statistics using summary, something we've seen before. And then there is another function we can use within the psych package called the describe function. And since this says could not find function describe, we want to make sure we load in the psych package in the top part of our markdown. Hit Control Enter, and then it'll run that line, and now it'll show us some more descriptives than what summary provides us. Another way we can look at the data is to subset the data. So let's say we want to look at those who identify as female. We can use the filter function within the tidyverse to subset the data. So it follows the same structure. We first start off with the name of our data set that we want to use, then a pipe operator, then some data wrangling functions. So for us, it'll be filter. And then within filter, we want to specify the variable name and then the operator. So we could have done greater than, less than, 2 equal signs, or greater than or equal to. So for us, we want exactly females equals 1. So we know that females is 0s and 1s, 1 for female, 0 for male. And then we want to insert another pipe operator after we have our data wrangling functions and input some type of function that we want to use or to look at the data set. And here it's describe. So when we run this, now we'll just see that same output, but only when female equals 1. So here we can see descriptive statistics for females only. So now we can check for missing values. How are missing values identified? That's something I mentioned in part 2, that MplusAutomation should already know what your missing values are, because R specifies the missing value for you, and you want to make sure that sometimes you don't have to specify it yourself. So let's see how they're identified. So if we see that it does identify missing, so it knows that that period is a missing data. And so when you open it in Mplus, it'll show up as NA. So now we don't need to do anything. We can recode a continuous variable into a factor. Let's try school belief. So it's the same structure. You have the existing data set you want to work with, a pipe operator, data wrangling. So here we just want to select one variable. We're not creating a new object because we don't have the arrow in front of it. And then we can use the summary function to quickly look at the variable. So we can see that the values range from 1 to 10. And so we can recode the variable to look like low is 1 through 3, mediums 4 through 6, and high is 7 through 10. We can use the cut function to divide the continuous variables into intervals. And so here we'll I'll break down what this code chunk does. So we're going to create a new data set object called school factor. We know that it's an object because we have this arrow in front of the name. And then we want to use an existing data set, new names, a pipe operator, and some data wrangling. So we want to mutate. What mutate does is changes a pre-existing variable or creates a new variable within the data set you specified. So here we want to create a new variable called school factor, and it's going to be whatever I tell it to be here. So with the cut function, we want to take the existing variable that is already in this data set. And then within the cut function, there are two arguments we can use. One is the breaks argument to specify where we want to break the variable. So from 0 to 3, 3 to 6, and 6 to 10. We use 0 at the beginning to ensure that 1 is included in the first break, then break by the last number in each section. So we know that low is the last number in, or 3 is the last number in low, 6 is the last number in high, and 10 is the last number. Sorry, 6 is the last number in medium, 10 is the last number in high. Then we add labels to specify what the factors are. And then we can look at it using this code here. So now we see that this was our previous variable, and now we've changed it into a factor. Other things we can do is look at new normality and distributions of the variable. So we can look at density plots using the GG density function. And so what you would do is take the variable, the data frame, then add a number sign to specify the variable name. So when you see a $sign, then you know that this is the data frame name and this is the variable name. So if let's just say I didn't have this and I want to specify new names, and then I add that $sign, it'll tell me which one I want to select from. So I don't remember what it was before, but we can just say it's this one. Oh, right. So now this is an error message letting me know that it could not find function GG density. I have to make sure that it's specified up at the top. Just need to remember. Oh, right. It's GG. Hub R. And that now it'll work. And now we have a density plot for this variable. We can also look at histograms using the hist function. We can also look at QQ plots using the GG plot, and then a box plot using ggplot. Ggplot is a popular function used to plot data, and it usually starts with the function name ggplot. Then we have aesthetic or AES function to let us know what variables we want to use. And for box plots, we just need one Y value, which for us would be the name of the variable we're interested in. And then you have to let it know what type of plot you want to see. And here we want to see a box plot. We add a plus and not a pipe operator because this is part of the ggplot function, not a separate function, separate than the ggplot. We can also look at bivariate scatter plots. Same idea here. We have here is X equals school belief 1 and Y equals school belief 2. You don't have to specify X and Y, but it will go in order. So if the first variable will be X and the second will be Y. Then we add a plus to let it know what type of plot we're using, and here is point for scatter plot. We can add a line using the geom smooth function. You can also add a theme. So if we didn't have theme minimal, it might look a little different. So this is more of the base default theme, but theme minimal does look a little cleaner. The pairs function also goes through your entire data set and creates a bivariate scatter plot for each. Let's see if I can scroll. For each pair of variables. We can also look at bivariate correlations using the core function. So here we have the data set. We need to remove any missing data for this function to work. We're using the method Pearson, and we're rounding to 2 decimal places. Let's see. Here, we also need to make sure that we load in the function for core plot. So this gives us 2 plots. This first one is, I guess, a bivariate correlation table. And then this one is a fancier one that's a bit more colorful. And finally, we can look at skewness and kurtosis using the describe function, and we can specify a certain variable. We know that the skew value less than 3, we want it to be less than 3, same with the kurtosis value. So we can look here that they are both less than or greater, not less, they are not, they are between 3 and -3. Great. One thing we can do when we're done with our markdown is knit it to HTML. And then we can see that it has everything that we did in our markdown, including the output. Unless we say we don't want the output included, then it's going to include it, because in the setup code chunk we have echo equals true. And we also have the library function messages. So what I like to do is take that out using warning equals false and message equals false in the setup code chunk. So when I reknit this, oops. It removes all those warning messages that comes with the function when you read in the packages. And now we have everything that we did today. And that's it. If you have any questions, feel free to reach out. And thank you very much.